Let's solve question 6. So in question 6 we have a function f of x equals to x cubed plus 2x squared plus x plus 5. And we want to find out at which points the tangent line at this function at x equals to 0 and f of 0 lies on the graph of the function. Okay, so before going further, let's actually see what a tangent line means. The word tangent comes from to touch, so a line that touches our graph. If we have a function on the xy axis, so x, y, the origin, let's draw the function as an example. Maybe the function would look something like, let's actually extend it a bit, just to make it a bit more realistic. Maybe the function looks something like that. And we want to know the tangent line at the point of 0, f of 0. So 0, f of 0, it means when x equals to 0, over here, what is the value of y? Well, the value of y on our graph corresponds over here. And the tangent line is the line that touches our graph. So this would be the line, it has to be a line, remember, that just touches this point. So here is how it touches. Now what is a line? Well, a line has the shape of y equals to m times x plus b. So it has the intercept and it has the slope. Okay, so our tangent line has this form, mx plus b. What can we find out first? Well, we can find out the derivative. We can find out the slope. What is m? M shows us the rate of change in y relative to x at this point, which is our derivative. Can we calculate the derivative of the function at this point? Well, of course, because we have the formula of the function, f of x equals to, so let's write it here, f of x equals to x cubed plus 2x squared plus x plus 5. And based on this function we can find out the derivative. So let's calculate the derivative. Let's differentiate this thing. So what are we using here? We're going to use our power rule. When we're differentiating x to the power of n, that's just n times x to the power of n minus 1. Okay, so let's do it. What would be x cubed derivative? That would be 3x squared. So 3x squared. What is 2x squared derivative? Well, 2 is a constant, so it stays the same, times x squared derivative would be just 2x. 2 times x to the power of 2 minus 1, which is 2 times x to the power of 1. Plus x derivative is just 1, and 5 derivative, well, a constant has no rate of change, so it's going to be 0. As a result, we have 3x squared plus 4x plus 1, which is the derivative of the function with respect to x. Well, this is the general formula for our rate of change, for our derivative, but we want the exact value at the point of 0. So we want to know the derivative of the function when x equals to 0. So that's what we're looking for. We're looking for f derivative at the point of 0. That's equal to 3 times 0 squared plus 4 times 0 plus 1. So we're literally plugging in 0 into our general formula. And that's equal to 0 plus 1 equals to 1. That's the derivative at the point of 0. That's our m. That's our slope. We already found out something. We found out our m over here. This is 1. Let's write it. That our tangent line, it's getting a better shape now. It's getting to a real line. Let's call it yt. Y stays for the fact that it's a line as a function of x, t for tangent. The slope is 1, so 1 times x plus b. What we're looking now is for the intercept. What is the value of the intercept? How can we find out the value of the intercept? Well, we can find it out because we know that we're looking for the tangent line at the point of 0 when x is 0 and the function has the value has a result for x equals to 0. So what that means, we can substitute x equals to 0 and we'll get the value of y. So let's do it. What is the value of the function when x equals to 0? Well, when x equals to 0, the general function f of 0 equals to, let's substitute it here, f of 0, let's calculate it over here. F of 0 equals to 0 cubed plus 2 times 0 squared plus 0 plus 5, and that's equal to 5. So the function at the point of x equals to 0 is 5. Okay, now with this in mind, what does that all mean? That we have this tangent line and we have the fact that f of 0 is 5. Well, we can substitute that when x equals to 5, when x equals to 0, y equals to 5. So we have 1, the slope, times x equals to 0 times 0 plus the intercept, which means that 5 equals to 0 plus our intercept, which means that the intercept is actually 5. That's what we did all this thing over here. We worked with the value of x, the value of y, to find out our intercept. And now that we know our intercept, we could actually substitute it into our tangent line and write it as a general formula, that the tangent line is equal to the intercept of 5 plus the slope of 1 times x, and that's it. This is our tangent line. And that's just part of the question, because we want to know at what point does the tangent line stay on our graph, touch our graph. Well, we have to equate the tangent line with our original function. We have to make our tangent line equal to our function. That's what it means to have the common points. So 5 plus x equals to the function of x cubed plus 2x squared plus x plus 5. Okay, this is an equation. We have x plus 5 on both sides, so we can cancel out x plus 5 and x plus 5. We're left with 0 equals to x cubed plus 2x squared, and that's it. What can we do next? We can take x as a common factor. So if we do it, let's do it over here. If we take x as a common factor, we're left with x squared from the first term plus 2x from the second term. And actually more than that, we can take, let's actually do it once again, we can take x squared as a common factor. If we take x squared as a common factor, we're left with x from the first term and 2 from the second term. And that's equal to 0. When can a product equal to 0? Either the first term is 0 or the second term is 0. So it's either x squared equals to 0 or x plus 2 equals to 0. Which means that either x is 0 or x equals to minus 2. So at these 2 points on our graph, the tangent line will touch our function. And that's it. We are done.